Thank you so much for having me today. I wanted to use my time for introducing how you can use AI in different projects related to climate change. And I started also calling the title machine learning because really when we talk about AI these days, we're talking about machine learning. So machine learning is referring to a group of technologies that automatically extract patterns from usually large amounts of data. And I wanted to just start us off by explaining how machine learning is different from what we used to know of computer models. So typically when we program a computer model or simulation, we know the function that we want the computer to display. So for example, if I want to know the volume of this room, I know it's width, length, and height that I need to multiply to get the volume. So we put in the function, we put in the data, so the measures of the room, and then the computer program, the computer model gives us an output. So that would be like a very, very simple simulation. Obviously, often those models are extremely complex, and you definitely need a computer for getting these outputs. So a machine learning model works completely different. So for machine learning, you would collect a huge number of rooms and record the width, the length, the height, and you also record the volume. And then you feed in that data, you tell the model also use a neural network or a type of machine learning algorithm, and then the computer figures out what's the function. So it learns itself how to map from the measures of the room to the volume. And in this case of the room, this is actually, you would ask, why are we doing this? I mean, we already have the equation, this is much better. But often you actually don't know the function, you don't know the equation. And that's what makes machine learning really, really strong. So you can actually infer from observations what's the underlying function and use this model then to make further predictions. So to illustrate, we can, for example, feed in pixels, like those two images, and we can have it learn a label. So here, the computer would learn itself the function from, this collection of pixels, which is the image of a cat, or this collection of pixels, which is the image of a dog, to map to the label cat or dog. And if you would need to tell a computer how to do this, need to actually explain this, you would have trouble, right? I mean, people would maybe go and say, okay, there are pointy ears, so it has to be a cat, but how do you tell a computer that that collection of pixels is pointy ears? So this is really where machine learning is so strong, is when you don't actually have this function, but you have a lot of data. Okay, so that's the very simple view. So what can we do with machine learning for climate change? And a few years ago, I wrote together with a number of other researchers an overview of how you can use machine learning in climate change mitigation and adaptation in science. So I cited this here below, but I wanted to today walk us through some of the main ideas that we found, how you can use machine learning, and then also address some examples. So you can use this ability to read out pictures or other complex data like text, for example, to gather new information at scale. So you can read out huge amounts of pictures or read out huge amounts of text, which previously you could only do manually with machine learning. And that helps you to monitor crop health, for example. That's an example I'm going to address, or monitor greenhouse gas emissions remotely from satellite images. You can create better forecasts with machine learning. It learns really well from historical data to forecast sequences that's being used for renewable energy forecasting, also in transportation systems and in many more circumstances. You can embed machine learning when you're operating, for example, engineering systems like heating and cooling systems, or even a food supply system to minimize waste. You can also use it to improve maintenance of engineering systems. You can, for example, remotely detect natural gas leaks, or you can analyze sensor data and understand when equipment might be about to fail and fix it before it fails, which reduces costs and also makes systems more resilient. Machine learning is also being used in the lab. So new batteries or next generation clean energy materials are still incredibly important for the energy transition. And people need to run a lot of experiments in the lab. And what they do is that they use machine learning to learn from past experiments to suggest them those experiments that are more promising. And that actually can speed up the processes by quite a bit and help them understand materials in the lab. And the last thing that I wanted to highlight is that where one actually has a simulation, which is very computationally and time intensive, like in many circumstances, and we're going to see one soon, you can use machine learning to speed that up. And that improves climate science, those large climate models that they make them more granular and have actually local forecasts that way. Or you can use it in city planning, which I will address. Okay, so let's dive into the first example to make this a little bit more, I guess, easily understood, because that was pretty abstract so far. Okay, so we have the issue that agriculture is very sensitive to extreme weather events, especially droughts or rain, and those are aggravated by climate change. So what one would want to do, ideally, is monitor the yield, agricultural yield at scale, using things like satellite images or aerial imagery. So you could actually understand the crop health at the scale of countries or regions. And this is something that, for example, NASA Harvest does. In Europe, it's also the Copernicus program. They monitor the vegetation health or crop health through remote sensing and satellite images with the help of machine learning. So the computer vision techniques from machine learning are incredibly helpful for remote sensing. The entire field has really made huge leaps with machine learning. A very different example is for district energy. So I'm sure that many of you even work with district energy, and those are incredible, important technologies for incorporating, for example, waste heat, and therefore using renewable heat sources for heating homes. And you need to have good forecasts in order to schedule the different heat sources that you have in your network or in your grid. And what machine learning, for example, can be used for is improving those forecasts based on different types of data sources, historical heat generation, metering data, and environmental data is what they used in this example. So this is a project from DENA, the German Energy Agency, that used machine learning in this way. Also wanted to touch on an example from my own group. Here we looked at climate risk disclosure. And this is an example where machine learning is applied to texts. So there are huge financial implications of the risks that companies are facing due to climate change, both to the physically changing climate and to the transitions that we're undergoing, like the energy transition. And there have been a number of policies that are encouraging or mandating such disclosure of risks in, for example, annual reports of companies. So what we did, we wanted to understand is, do companies actually talk more about these risks? So we took machine learning to help us analyze thousands of annual reports and actually come up with such a plot where we could say the number of mentions per report over time. So you could actually show that way that the number of mentions of climate risk is drastically increasing over time. And that we wouldn't have been able to do manually because we couldn't have read thousands of reports. And the last example is from urban planning. So here we're talking about designing actually new districts which are very important for having sustainable cities in the future. I mean, a lot of districts are actually being built these days, and you want to design them such that they're walkable. So in winter, it's not too cold. Then in summer, there are no like heat islands that emerge. And for that, you need to understand how the wind flows through the city, which is an incredibly complex thing to model. And these simulations, they take hours or days to run. So it's not really useful if you want to design a district. If every time you change a little bit your layout or your design, then you actually have to rerun this really expensive model. So what people do is they actually approximate these models with the help of machine learning and bring those runtimes down to seconds. So that way you can actually try out many different configurations and do that in real time, essentially, get results in real time. So you see that we have many different kinds of applications of machine learning, and typically machine learning is or AI is one tiny piece of the puzzle. So you already have a climate solution that is much broader, and you have analytical approaches to it, and then machine learning sort of gives that new ability to it, which makes it so exciting. But it's not that AI just comes in and fixes things. It's really like a very analytical approach to a solution that's much broader. So I also wanted to touch on some limitations of the technology, which I think are important to understand. Typically, models need to be customized and actually trained on the data of the specific project, of the specific use case, which is really in contrast to the AI that one often sees, like ChatGPT. Those large language models, they really come out of the box. So, you use them for your thing, but they're really the same model. If you're using machine learning in the real world and in most other applications, it's very tailored to the different problem cases. But yeah, one thing that's true is that you need lots of data, and sometimes you also need a lot of compute. That again depends highly on the type of model that you're using. But definitely the data is a crucial underlying requirement for machine learning. Also because in the beginning, as I explained, everything depends on the data set that you're feeding in. And that also relates to this principle of garbage in, garbage out. If you feed in bad data, you get bad results, or you get bad model. So you need to have data that really represents what you actually want to learn, what you want to do, and you need to have data that's clean. Machine learning and AI is not objective. It's inheriting a lot of bias from the data, from the design, and also the way you use it. So it's not better than humans in a way that is objective. And you need to have data that doesn't change over time, or if your data changes over time, you need to adapt the model. So the patterns that the machine learning model learns, they sort of need to be persistent, or it assumes they are persistent. And it may not work if the underlying data changes. That also means that long-term forecasting is notoriously difficult for machine learning. And it finds correlation, not causation. This may be a very statistical thing, but we are sort of in the realm of prediction, so it doesn't really explain anything to you. It's just a model that's really good in predicting what you want to know. Okay. So I put a list together of benefits and costs, which are still really poorly understood in most real-world applications, but roughly you can think of the benefits that machine learning or AI enables new types of working or improved types of working. So concretely, it can generate insights where human expertise does not exist, or where you cannot make it explicit. It can also perform tasks that humans can do in a way that's cheaper and more scalable. That also hints at this great fear of machine learning replacing humans, but it's really doing that thing. It's saying, okay, we can have a human looking at an image, or we have a model looking at an image, and therefore we can scale this by much more. And then, of course, depending on how you use it, it can occur some operational efficiency, and therefore, save costs, save energy, and so on. On the cost side, of course, you need a lot of data, as I said, and you need IT infrastructure for having those data, and you need data management. So you need quite some digital infrastructure for training those models. You need people who can train those models, or you need to find a partner that can provide those AI expertise, which is a trivial point, but a crucial point, and actually a huge barrier, I think, to many projects. You are never guaranteed that machine learning is actually helping you in a given situation. So it's lots of trial and error, and sometimes actually simpler methods turn out to be the better approach. And those models, as I said, it's not a one-off, so you need to maintain and you need to retrain them, as one says. So you cannot just have somebody come and give you that model and it runs for the next 10 years. Likely data is going to change, the world is going to change. Pre-COVID, the word COVID-19 didn't exist. Afterwards, models have to be able to deal with it. So, these kind of subtle changes in the underlying data will be important, and you will need somebody to update the model and check it regularly. And then, of course, it also poses challenges for the people working with these models, which can be overcome. But I think there's a lot of, it's actually a much bigger topic even, like how explainable are the outputs? Can I trust the model? All of these considerations are there as well. So this is to say, this is a very abstract way to look at the benefits and costs, but really we need to understand better where is machine learning applicable, where is it really having a net benefit, and where would one be fine with simpler approaches. And for that, we're actually also doing research in my group where we're looking at cities in particular, and we're interested in what are the motivations and what are the barriers for municipal governance to actually explore machine learning for climate change mitigation. And there are quite a few projects ongoing, and we are interviewing the stakeholders to understand that better. How do they perceive the risk and benefit from those projects? What do they learn in those projects? We also looked at a large body of literature to understand better what kind of applications exist for cities in this space. And we found that there's a rapidly evolving research field. We see a lot more research coming up. So this paper is in review, but the preprint is already online. And we found that those impact areas, those areas that we identified that are most in focus, also match with what the IPCC thinks is most important for addressing climate change. And we found, as expected, a bias on Eastern Asia, Europe, and North America, which are also the regions of the world which are most strong in AI, and also there are the most studies on municipal climate action with machine learning. So with that, I wanted to thank you, and I'm looking forward to your questions and also your input.
Thank you so much, Lynn. Thank you very much. So, yeah, Lynn can take a seat already, because actually now she would like some input from all of you, and she's prepared a couple of questions for our audience that is very important for her research. So I hope you will be supporting Lynn's research. And because this is about digitalization, of course, we want you to participate digitally. I see everybody knows what to do already. So scan the QR code. The only thing that you need to know is to type in the room number 1736. That's the most important thing, because other sessions will have another number. If you don't want to scan the QR code, you can also open your browser and just type in tedme.com. But I think the QR code is probably the quickest way to do it. Is everybody with me? Okay, still some people working with their smartphones. Just give you another moment. Okay, so don't forget to type in the room number. There we go. So the question that Lynn has prepared is, do you know if AI is appropriate for your project or projects? And you can pick from a bunch of different options. Yes, we've started using it, or I believe so, but I need to know more to find out. No, it is not applicable. No, it would be helpful, but the effort and costs are prohibitive. And the other option is no, because I'm facing other barriers, institutional, legal, and so on. Or, I don't know. It's also an honest answer. And we have some people who were honest and said that they just don't know how to answer the question. So Lynn, are we ready to take a look at some of the results? So it looks like people do seem to think that AI could be useful, but they're not quite on top of what's necessary to actually make the most of it. What does that tell you?
Yeah, I mean, so we asked this question because we just wanted to understand, what's the attitude, and especially we, I think, expected that not many projects are yet using AI, but I'm actually positively surprised that we have 18 answers of the projects that actually have started using it. So I think this kind of reflects what I expected. And if I'm saying we, it's my one PhD student and I. So this is not directly going into a study, but we're curious to hear more of ongoing projects in Europe that are interested in this. And I hope that this is also an inspiration and an invitation for the workshop later to speak to me or speak to us. And if you're actually interested also in speaking more about what you're seeing, also if you're even facing barriers like institutional or legal barriers, if you're not yet applying AI, and if you want to speak to us, that would be interesting, because she's currently conducting stakeholder interviews with cities on these topics.
But I think it's also a reflection of the nature of our audience. People are curious, and they want to find out more how to boost their own work with any tool that's available to them. And there's so much potential in AI and machine learning. Why not tap into those benefits? Okay, so I think we have one more question that we prepared for you, or I should say Lynn prepared, and to hear from our audience, what is your main motivation to use or explore AI? So lots of options to choose from, so you got to read through them first. You want to help accelerate progress on your work in climate action, or you want to use automation for more effective use of human labor, or to showcase data-driven innovative approaches, or to help make better decisions, or get better information about either the city or the project region, or provide new or improved services to citizens or users, reduce costs, or shape or support the local AI market through urban public sector demand. So yeah, so lots of options to choose from there. Maybe some of you have to think about it for a second.
And I think one can choose several options.
Yeah.
No?
Can you choose more than one? You can just choose one.
Okay.
So if you have to choose one, but it seems like already the trend is pretty clear. Does that surprise you, Lynn, or is that what you expected?
So, I mean, I was hoping one can choose several, because they're sort of not mutually exclusive, of course. So, yeah, I mean, automation seems a strong motivation to use machine learning, so that doesn't surprise me. I think that one interesting point here is C, because I think a strong motivation is also to showcase maybe to constituents, to citizens, that one is sort of going on an innovative path, or for oneself even to try out this innovative new technology at this also combined with the green transition. So I'm actually happy to see that quite a few chose this option, because I think it's, for many people, like a main motivation to try out pilots, and it's an honest answer, I think. Yeah, so I would have thought more answers would be H, maybe, because there has even been a program on public procurement that was tailored towards this goal of helping local AI startups or small organizations develop products that they would sell to the municipality in that case. That was AI for Cities. It was an EU-funded project. So I would have expected that maybe there's more of that as well.
Our audience can surprise you as well. All right. Lynn, please do stay where you are. I know we're going to be talking about all of these things a little bit more, but up next, we would like to hear from our second speaker. As I mentioned, there she is. She's joining us virtually, so we can already see her. I don't know if the rest of us can already see her. She is an honorary professor in the Institute for Innovation and Public Purpose at UCL in London. She's executive board member of the Italian public media company RAI, and part of the high-level roundtable for the new European Bauhaus that was set up by EC President Ursula von der Leyen to accelerate the EU Green Deal. So a woman wearing many different hats. And ladies and gentlemen, let's have a warm welcome for our virtual speaker, Francesca Bria.
Hello, hi, I hope you can hear me well. It's really a pleasure to be with you today, and sorry for not being able to be in Berlin in presence. My presentation will focus on, let's say, looking at urban data and artificial intelligence as digital commons, which means I'm going to look at the governance model, at the policy model, but also make concrete examples on how using digital innovation or data-driven innovation, and of course with the help of machine learning, we can address some of the fundamental challenges, which are social challenges, which are also the broader multiple crises that we are living on the moment. Also to basically show that in the face of this polycrisis, as experts call it at the moment, we have wars, we have public healthcare crisis, we have, of course, the climate emergency and the need to go towards energy transition, we have inflation, we have the kind of jobs market that's all the time not stable. And I think that Europe, in a kind of broader sense, made a very important bet towards this twin transition, as we call it. On one side, the Green Deal and the green transition, and on the other side, so moving towards a carbon neutral future, and how that's related to the digital transition. And the digital transition is about being able to use the digital infrastructure, data, sensors, artificial intelligence, but also to direct it towards more environmental and social sustainability. I think we all experienced during COVID in particular, but also now, a certain acceleration of the digital transition. So our digital tools enter every aspect of our life, platforms that we use, apps that we use to do everything. But what's really important is not only to accelerate this digital and technological transition, but to give it a direction, to align it to the social, environmental sustainability that we want to achieve. When we look at the climate data and the environmental crisis that we're facing, and we do this very much in our new European Bauhaus group with the European Commission President. We have what we call the elephant in the climate room, which is the built environment, which means cities. So cities are responsible for 40% of global GHG emissions, and 55% of developed waste countries is produced in cities. So cities, or let's say our urban environment, they have a very important role to become new carbon sinks, to switch from a dumb linear petroeconomy to a smart circular bioeconomy. To do that, we have to really transform our cities, to really transform the built environment in terms of mobility, in terms of course, caring about the climate and the pollution, but also transforming the way we live and work, transforming the materials, transforming logistics, and so on. We can only do this starting people first. In the introduction, it wasn't said, but I've been working many years in cities. I used to be the Chief Technology and Innovation Officer of the city of Barcelona. And I was also coordinating a large network of chief technology and innovation officers globally that were using, in fact, digitization and data and artificial intelligence to improve cities. And I also worked for the UN Habitat, which is the United Nations body taking care about cities, in order to create the first programs that are digital first, but also people first. So I'm really convinced that if we want to achieve this carbon neutrality, these free emission cities by 2030, and this is one of the big aims of the European Union at the moment, we have to start with communities, we have to start with people, and we have to bring people along. So this requires also some form of participatory democracy. So this example that you see here is a very important planning experiment. That's the Barcelona Superblock. The Barcelona Superblocks has the big aim to reduce of 20% car rides by 2024, which is actually this year. And they remove cars from the city centers and allow cars only to circulate around specific blocks, so these super blocks that you see there. This creates 10% of new green areas. It doubles bicycle lane, and also it goes together with an ambitious mobility plan, like an electrification plan. This example of the Barcelona Superblock radically transforming our city centers, removing cars, making it more green and more livable for city, show how complex are these urban environment experiments, and how, for example, yes, of course, you need to enter with all the tools at your disposal, with sensors, with infrastructure, with measurement tools, with data and AI to achieve those goals. So the Barcelona city wants to create 1 million square meter of public space that, instead of being used to traffic, I know this sounds strange for German cities where you have a lot, of course, of cars in city centers, but many cities around the world and in Europe certainly are moving cars from the center to dedicate spaces to more sustainable mobility, green streets. As you can see, these are some examples of how you can transform neighborhood, but also create new social infrastructures. So the aim is to have 1 out of 3 streets in the city that are streets for pedestrians, green area, and sustainable mobility. Here you see one of the rendering, which are called the green axis, and you can see how, of course, the city becomes completely transformed by this kind of intervention. And if you couple, of course, the ambition of getting 80% of municipal vehicles electric and also 30% of buses electric in the city, you understand how that would also have a strong impact on sustainability, on social infrastructure, but also on the livable environment of the cities and in Barcelona and beyond. I think in cities in particular, it would be very, very exciting to combine these different layers, the net zero and the climate neutral actions with data and participatory democracy. As I was telling you before, the involving citizens in the decision-making process, in participating in those kind of actions, is absolutely critical for the success of those plans. And with digital tools, and not only, so with a hybrid method of online democracy and offline democracy, is now today possible to extract collective intelligence from people and to move towards a more participatory democracy. To make you the example here, you have New York City, also Helsinki City, Barcelona, Madrid, Milan. Many cities are taking this participation and deliberation of citizens in a very serious way. in the city of Barcelona, we had 70% of the city action plan that was taken together with citizens. And they were really part of trying to understand how those projects were transforming their environment. So data in this kind of aspect is absolutely a critical part. You can see how with monitoring, for example, using data and digital infrastructure, taking data coming from sensors network, taking data that we produce as citizens all the time, you can monitor the energy grid and the energy monitoring remotely. You can have water metering. You can, of course, intervene in the parking and transportation system, but also help with garbage collection. So it's really the data becomes a new meta utility, a new fundamental infrastructure layer that can create public value, that can mobilize resources and help policy makers, but also all the stakeholders to scale their decisions and take better decisions, which are informed by evidence. But of course, we need to govern this data, because otherwise it's impossible, because the majority of the data, as we know, there is a lot of imbalance of power. Much of this data and intelligence is today in the hands of very few companies, the big tech companies, of course, that we use every day. So in order to, let's say, shift the power balance and make sure that artificial intelligence and data can be really used in public interest to transform the city for the better, to really empower the citizens, we have to govern this public data, which was also, I think what it was said before, that we not only need computing, we need, of course, people that are able to manage these systems, but the data needs, let's say, to be seen as a public infrastructure, as a digital commons that we own. And in fact, citizens, when they pay taxes, they also pay for the data that today is collected and is part of the intangibles, let's say, that give value to the service. So I've been working a lot in Barcelona to transform public procurement, make sure that when we procure services, we also own the data. So the data becomes owned by the citizens of the city that are paying the taxes. And with the city of Hamburg, we made a very interesting experiment focusing on mobility data. We ran a data challenge in order to collaborate from the city administration with startups, with creative communities, with developers, with universities that have the skills and the capacity to build the application using urban data. And then we basically worked with the companies that have very important urban data to transfer the data from private to public in public interest. So this data can then become, let's say, managed in a data trust according to specific rules that, of course, on one side preserve the privacy of people, preserve their information self-determination, because we know that many people are also worried about this constant tracking and constant monitoring. But on the other side, this data can unleash an entire capacity, an entire ecosystem of sustainable innovation in this, let's say, collaborative process with big companies, the cities, and small companies which have the knowledge and capacity to build application on top of this very important data. I think the objective here is to show that this is a new way, basically, to manage this city. For example, many cities today have local digital twins. These local digital twins are built with modeling. So you get the data, you create machine learning, you build your LLM or your model of the city, and then you can experiment things with your urban twin. You can do small experiments and then scale the city service when this works in the real world environment. So these success cases are happening in mobility, in climate, in housing. But my recommendation here is that it can really work for the people if we are managing it as a kind of public infrastructure that empower communities really on the ground. Many cities are today developing algorithmic registers. So there are, for example, this is from the city of Amsterdam, there is algorithmic systems, and citizens can go on the website and see what kind of algorithmic systems the city is using, how they are using the data, and how they're taking decision. And this is, of course, it's done because, as we know, there is a lot of biases. There is bias in the data because the data has to be clean and it has to be kept and maintained well. But there is also a lot of biases on how this data can be used to discriminate based on gender, based on race, for example, based on socioeconomic belonging of people. So it's really very important to be transparent, to train city officials to use these systems and to do it in a way that citizens themselves are able to track and see what is happening with these AI systems. So just to summarize, I think that building smart cities based around data sovereignty, citizen participation, and putting technology at the service of the green transition, it's fundamental today. But to do that, we have to understand data as a critical urban infrastructure. We will have to work with our procurement system internally to, for example, add data sharing and data sovereignty obligations in procurement contracts and in public tenders. So this is well governed and well maintained. We can create data commons repositories so that cities can learn from each other. I think one of the questions before was, do I have enough capacity to do this? Well, if we create this kind of learning environment where cities can learn from each other, where organizations can take the governance model, can share examples, can learn, can maybe even reuse applications from other cities, that we're going to be able to do it in a way that's interoperable and in a way that really bring the benefits that we want to see. And of course, finally, the data-driven approaches can enable citizen participation. I insist with this part because I think that democratic decision making via a large-scale participatory democracy is very important also to be, let's say, against this kind of lack of trust that we see in technology when the changes are going too far. Let me just end my presentation saying that this is a very exciting moment in Europe. If we think about that, Europe wants to be seen as a new leader in the digital and responsible innovation, but putting really democratic values and citizen at the center. And so let's say maybe distinguishing itself from the Silicon Valley big company, big tech company model, and from the Chinese model that's aggregating, I mean, let's say digital authoritarianism. What Europe wants to do is to show that it's possible to do it based on rights and democratic principles. And the fact of how we can, do data management, increase access to data while keeping the trust of citizens and consumers, I think it will be one of the most important and critical policy questions in the future years. And for this, of course, there is the Data Act, which is a regulation, the Artificial Intelligence Act, which is another regulation at the European level. And then Europe it's giving itself the possibility to have their own infrastructure and European data spaces in critical areas like healthcare, manufacturing, mobility, and culture. I mentioned this because I think to get it right, we're going to have the right infrastructures, but also really to make sure we convene to citizens that this is a leap in their future where it's going to be very important to manage data, digital identity, payment system in a kind of new form of digital citizenship. So it's very important to have these public digital infrastructures and what I've been calling a European stack to put individuals and community in control, or whether they want to keep their personal information private and so give the tools to maintain their anonymity, their privacy, but at the same time the choice of sharing the information for the common good, and also so that it can shared and it can process by artificial intelligence system, by machine learning systems, and give us the output that we want, which is desirable for society. So I'll be quick here, but just I would like to mention that there are a lot of political and ethical implications in the development of artificial intelligence in the future. First of all, there is a need for regulating the big tech power concentration. As we know, there is a lot of work coming with antitrust and regulation at EU level. Also, we shouldn't just trust the AI. Sometimes the AI gives us stupid responses, or it's not correct, or it's hallucinating, as we say in industry term. There is a lot of also environmental cost, a lot of energy is used, a lot of water is used. So there has to be a lot of in the future, but also today we have to work a lot to decrease the need of the environmental costs that are coming out of the machine learning system and the big compute power that's needed to have these AI systems in place. And then we have to be, of course, very careful in a year like this, a year of election, of information manipulation, of disinformation, of fake news that can be powered by AI. So a lot of challenges, but at the same time, basically, I'm very confident that we can design and govern data and AI for the common good, and that Europe, but in particular bottom up, coming from organizations like yours, cities that are really willing to experiment with these systems, to start from real world social and environmental challenges and then use them to deliver a good desired output. I'm very confident that we manage also to show how, in fact, data and artificial intelligence can be governed in the public interest and can be addressing real problems, as it was shown also in the previous presentation, that otherwise we wouldn't be able to do it. So let's build together a European innovation model that starts from cities and citizens and that guarantees the full democratic participation of citizens and workers, protect the environment, our data, and also our fundamental rights. Thank you very much.
Francesca, thank you so much. There's so many themes to unpack in what you just shared with us. I do want to go right ahead and open it up to our audience for them to address their questions, both to you and to Lynn. So can we see quickly, there's another QR code for this sort of round where you can send your questions to our speakers, or if you want to do it the old-fashioned way, as I said, you can just raise your hand. There's a brave and traditional person who's ready to speak with a microphone right over here. So the gentleman in the glasses, there he is. Yeah, and I'll let you...
Okay. Good afternoon, everyone. Remigijus Lapinskas, representing Green Policy Institute from Vilnius, Lithuania. My question is related to the question of resilience to vulnerability, or let's say threat of attacks, for example, by different groups of bad people, let's say when we talk about the big data of the cities or governments and so on. So what are your ideas, how you are going to protect that system? Because it could be used for very good things for people, but also could be used the same way against people. So what's your idea?
No, Francesca, do you want to go first? I mean, I'm not a cybersecurity expert, and so I really am not qualified to speak about that particular question. So, Francesca, if you have a general.
Well, I think in general, it's not only a problem that concerns AI, it concerns all the IT infrastructures that we have. And in fact, there is an entire cybersecurity strategy that is happening at a European level. There is coordination between bodies that are looking at this, and of course, more investment in security, I think, in general. So I guess it's a very important point to be addressed, and the protection of the systems in terms of privacy security by design, it's really important. important. And then, of course, to make sure, I mean, on one side is protected technically, which sometimes, as we see, even when we invest a lot of resources in IT security and in cyber security, things happen because it's a very dynamic environment, and as you said, is very risky. But I think to have a risk management approach, to have a risk strategy, many of these mistakes can be cultural as well. And I've learned also working in cities all the time that all the technology problems, all the technology issues are not only technical, but there is always a cultural and organizational element. So I would say, yes, of course, investing in security, have interoperability, have the entire strategy in place to resist to attacks, but at the same time invest also in the kind of soft approach, which is risk management strategy, the organizational part, and also the cultural elements that sometimes are also very important.
So maybe to add to that, that machine learning or AI is adding another layer of robustness or resilience issues. So machine learning systems are statistical in nature. So as we see hallucinations in ChatGPT, I mean, there are errors, random errors sort of, that occur with all statistical systems, such as machine learning. And there are even techniques that are attacked on those systems by modifying, for example, the data with which it learns. These are called adversarial attacks. That's actually a mechanism that's underlying all these generative models that we are seeing now. They are at times also using such mechanisms to train, but yes, there are new ways that you can fool these systems. Even fool them also when you're using them. So for example, systems that are detecting traffic signs, if you glue stickers on them, sometimes it completely fails. Or if you add like a, for human eye, unseeable noise to an image, sometimes it completely fails and makes, I don't know, cheese out of a penguin, even though there's like noise that you don't even see. So these kind of new issues with robustness also exist with machine learning.
We have a few questions that were sent in via the app. So let's take an app question next, and then we'll take another spontaneous microphone question. So someone from the audience sent in a very concrete question. How can AI help improve climate policy on the ground? How could it support EUKI's work?
I'm happy to jump in here because that's, I think, really close to what my group is working on. So I think one important point is really this ability to supply new information that's relevant for decision making. So support evidence-based policy making by, for example, using remote sensing to create new databases that then can be used for that. We're also working on transportation problems where we are predicting transport volume, for example, cycling volume in cities with the help of machine learning. I also showed an example of how we can ex-post evaluate policies in my slides, where we used it to understand how companies talk about climate risk in their annual reports. So even for understanding ex-post if a policy was effective, for monitoring, we can use machine learning here really effectively, because so much in policy making is also text-based. And we need natural language processing to make sense of those.
Mm-hmm. We have one more question, spontaneous from the front. Yeah.
Yes, thank you. Bodo Tjurisic from Development Agency of Podravje Maribor. In the past, since our agency is supporting different municipalities in our region, we have been trying to close the gap between the urban and rural areas. And now, of course, I understand that when you need big data sets for artificial intelligence to actually set up models, it's easy to apply them then in the city if you have quality data, not so much in the rural areas where you have very small data sets. Will that not, again, then widen this gap between the urban and rural, and how will this reflect then basically in the societal change, because we already see this discrepancy between cities and countryside regarding EU policies, regarding acceptance to actually go forward with when the change. So will this not cause additional societal problems?
I think, Francesca, that seems like a question for you.
Yeah, I think the question is very important, and I think, I mean, all the time, all different regions have their own specificity on this. Like, for example, when I've been working as president of the National Innovation Fund in Italy, we made very much a focus to go to the rural areas, internal areas, what we call, where there is less connectivity, less infrastructure, and less capacity, and make sure that there can be shared resources, and make sure that there can be collaboration with cities and rural areas. So I think this is very important, but for me, the concentration of computing power, the concentration of wealth, the concentration of everything in the city is just not going to be an answer for the majority of the places in Europe. And in fact, you know, when you look at the climate and the Green Deal strategy of the European Commission, we have invested a lot in cohesion policy. We investing a lot in developing infrastructures in places where infrastructure is lacking, and to basically, I think that's why I insisted a lot in interoperable systems, open source solution, reusable use cases, sharing the infrastructure, sharing the code, sharing the system. This is an approach, I think, to tackle the divides, in all possible divides, because it doesn't only happen with machine learning and AI. It happens with infrastructure, it happens with capacity and capabilities to, you know, to have literacy in the way we use technology, and then to be able to also use it to do something. I think it's very important to say that data has to be transformed in knowledge and in evidence-based decisions making a system. So we have to create the knowledge capable in order to use this data and then to scale the solution. And that's why we are using these systems, to make it more scalable, more robust, and more shareable. So I think those are very important questions that should be basically built in the system.
I think we have time for 2 more questions, so we'll take another one that was sent via the app, and then one more maybe from somebody raising their hand. Perfect. So hold on to the microphone. We'll read the question via the app. Somebody is asking, why should AI models be customized and newly trained? Isn't it redundant, and doesn't it have a worse carbon footprint than creating a one-size-fits-all solution like with ChatGPT? So maybe, Lynn, that's a good one for you.
Yeah, let's have climate machine learning 101. Yeah, that's a very good question, and I think it really has to. We need to dive a bit deeper into understanding machine learning to make this distinction. Essentially, what you're sort of pointing to is also different phases in the evolution of machine learning over the past years. So we came from a place where we really had to initially even had to customize the features, so the input data that we're working with, to a point where we are able to actually apply algorithms that themselves are able to make sense of the data and then run the model. I mean, I'm talking really abstract, so we're sort of coming from a more traditional machine learning to a deep learning era, where in deep learning, you already had much more built-in capabilities of the models. Those are deep neural networks, essentially, which is a type of machine learning model, to an era that we're seeing now with foundation models that are really expressive, really able to do these multimodal predictions, essentially can handle different kinds of types of data. So what is happening here is the models got larger and larger and incorporate more and more steps of the pipeline. And therefore, I think the most of the smaller models you have to customize really a lot, but then they work very well on a specific task of your data. What is typically has been the regime is that you sort of train them on, train only small parts of the model. So for example, if you have a computer vision technology, it's usually pre-trained, as we say, on a large body of data, but then we still customize it to our specific problem. And now we're seeing these foundation models, or these large language models, like ChatGPT, where you don't need to do this anymore because they are so able to deal with these general tasks that we have it do. Still, if you would ask ChatGPT to classify, paragraphs according to climate risk, it probably doesn't do so well if it understands what's climate risk. So you still need to fine-tune them to specific tasks, depending on what you're looking at. Or you wouldn't be able to predict, I think, very well the heat demand of a district energy system. So we would still need to fine-tune these models. If we're using such a big model, you wouldn't use such a big model in those cases. So this was hopefully not more confusing, because we could have a whole semester of a class on this. But yeah, essentially we're at different areas of machine learning, different tasks also. Those large models, they understand language, they generate images, so there's sort of specific tasks that they're really, really good at. And then the compute power plays a huge role as well. So I would always err on the side of a smaller model that does the job well enough than just going for the biggest available.
We have time just for that one final question. I just wanted to let everybody know who sent questions that we didn't have time to get to them. Hopefully you can ask these questions in the workshops and get some answers. Otherwise, you can try and find Lynn during the breaks and ask a question if you can. Francesca, you'll have to be contacted also virtually or remotely, but just for time reasons, we wish we could have gotten to all of them, but unfortunately, we have to sort of stay more or less according to our schedule to get to everything. Let's have our final question from the back of the room.
Thank you very much. My name is Anna Kolba from Zeve Center. I have a question or two for Professor Lynn. So in your presentation, you presented that you use photos for digitalization and machine learning. So my question is, I assume that the final output of this is some kind of GIS output layer, such a shapefile or something like this. So my question is, could you maybe tell us for some databases which are maybe not so well known, which have this kind of shapefile? First part of the question. And the second part of the question, you mentioned that you are mapping a heat demand. What are your, let's say, input sources in regard to the specific heating demand per square meter, or let's say, in general, based on the methodology you are using?
Sorry, I didn't catch the first part on a shapefile. What is that referring to again?
No, it was more like, could you maybe tell us some kind of open source databases which have this kind of, let's say, final output of the digitalization, but in some, let's say, kind of GIS editable mode, like in shapefile or in some other type of the, if you are maybe familiar with this, some kind of type of the file which are not, let's say, photo, but which are digitalized and which can be GIS edited.
So it sounds like a very technical, detailed question. So maybe you can give a brief answer for us, and then the additional details can be done during the quick break, because, yeah, it sounds like a very complex, multi-layered question.
Yeah, we can. I still didn't fully, honestly, didn't really get which shape files, but there are lots of open source databases out there, and that's actually a huge issue that you have to often to put in a lot of work to actually identify all the data. And I mean, people put in years of work to even also collect all the open source data that's out there and maybe create like a larger database. So I'm involved with one project where people went and they looked at shapefiles, for example, of building footprints and building heights and building ages. They collected all these data from all the different regions in Europe to create one unified database with basically everything that's out there on public data about buildings. And that took really long, many years, essentially, to do that. I'm happy to talk now offline if you want about the rest.
Okay, well, Lynn, Kaack, thank you very, very much indeed. And Francesca, Bria, thank you so much also. Greetings through the virtual universe. We wish you were with us in Berlin. And ladies and gentlemen, thank you for submitting your questions and answering the questions that we had for you. So many thanks indeed.